Hello again, ladies and gentlemen. Today we're going to be talking about Geometry Notes 1.2. So here our essential question is how to use the properties of parallel lines to determine angle measures. So here we're going to talk about, we talked about parallel lines in the past, but now we're actually going to be using some of the theorems that go along with it in order to figure out angle measurements. So we're going to go in a clockwise fashion, so we'll start with corresponding angles and go around. In the middle you'll see two parallel lines that is intercepted by a transversal. Now, before I told you that two straight lines like that meant it was parallel. Another way to tell if it's parallel are these two triangles here. So if you see these two triangles, then they are also parallel. Okay? So either we have the two lines up and down, or we have the two triangles. Those two will tell us if they're parallel or not. So because I got some other stuff to write, I'm going to go ahead and erase that. But you don't have to worry about writing that part. I just wanted to emphasize that. All right. So here, let's start with the corresponding angles postulate. It says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are, in this box, I want you to write congruent, and then there's going to be an arrow, and then I want you to write set equal. All right. So that means that the two corresponding angles will be congruent or the same. All right. So basically what that notice is, let's look at one pair of corresponding angles. Angle 1 is equal to angle 5. So if you look at it, angle 5 and angle 1, if you notice, they're in the same direction. And if you were to lay angle 5 on angle 1, they would be the same. So that's how you know they're corresponding, because one is inside, one is outside. They're also on the same side. They have to be on the same side to be corresponding angles. So angle 1 and angle 5 are our first pair. Then we have angle 2 equals angle 6. Angle 3 equals angle 7. And then lastly, angle 4 equals angle 8. So those are our corresponding angles in this particular example. All right. Next, let's move on to the alternate exterior angles theorem. That's going to be this one. It says if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are, again here you're going to write congruent, or the same. All right. So here, our pairs, the first pair we have is angle 1 is equal to angle 8, or congruent to angle 8, which we have a different symbol for congruent, but for right now we're going to say equal. All right, so that's angle 1 and angle 8. You see that they're both outside. The angle 1 is on the bottom left. Angle 8 is on the top right. So they have to both be outside and have to be on opposite sides of the transversal. Remember, the transversal is this line right here. Highlight it. That's our transversal. All right. So our next pair, if we follow that logic, will be, I'll do a box around those, angle 2 and angle 7. All right. So angle 2 is equal to angle 7. So those are our alternate exterior angles. We saw that, so we can start over for the next one. Our next one is the consecutive interior angles theorem. It says if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are, now this time they're not congruent, they're going to be supplementary. And we said before that supplementary means that angle plus angle equals 180. Okay, so on your Google form, you'll have to fill out supplementary, and I'll go ahead and, so you don't have to worry about these angle symbols, I'll put them in there, but you're going to have to fill out the 180. All right? So let's look at our first pair. Our first pair of consecutive interiors, so remember they have to both be inside and on the same side of the transversal or the diagonal line. Okay? So we have angle 5 and angle 3. So that means that the measure of angle 3 plus the measure of angle 5 equals 180. All right. Our next pair is angle 6 and angle 4. So that means the measure of angle 4 plus the measure of angle 6 equals 180. Okay? So here, another box I'm going to have off to the side, you're going to have to put same side interior. Okay? So that's just basically re-emphasizing what I was saying about they're both on the inside and they're both on the same side of your transversal or your diagonal line. All right? Let's get reset for the next one, or last one, at least in this rotation. And that is the alternate interior angles theorem. It says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are, and here we're going to put congruent. So if you've noticed, of the four we've talked about, the only one that's not congruent is supplementary. So that's the only way I can tell you to remember it. It's just remember consecutive interior angles are supplementary, not congruent. Okay? And if you look at the ones we've done in the past, most of them look the same. Consecutive interior, one looks kind of, well, acute, and the other one's obtuse, or, greater than 90 degrees. One is less than 90 degrees. So that's the way I remember it a little bit, but again, that might be a little bit more for you guys. All right, so here our first pair is angle 3 and angle 6. So that means that angle 3 equals angle 6. All right, our next pair is angle 4 and angle 5. So here we're going to say angle 4 equals angle 5. All right, so that will cover our little clock or little rotation. We have a couple of ones at the bottom we need to do as well. So vertical angles, we're going to fill out the box first. It says vertical angles are what? We talked about the bow tie. They are the same or congruent. All right. So our examples here are angle 6 and angle 7. That's two of our examples. There's actually quite a few. We're just going to do two examples. So angle 6 is equal to angle 7. And then the other one we have is angle 1 and angle 4. So again, angle 1 equals angle 4. So again, these form a bow tie. If you look at them, they form a bow tie. You kind of have to kind of scribble on this side, and then you can kind of see my scribbles. They kind of look like a bow tie. So again, always look for the bow tie, guys. Whenever you have two angles, if they form a cross or an X, 9 times out of 10, there's going to be some vertical angles there. So you want to look and see and make sure. And our last one on this page is a linear pair. We talked about this a lot in the Google Meet, remember? Linear pair of angles are not congruent. They're supplementary. All right? They're supplementary. So our first pair that we can say is angle 5 and angle 6. You notice that they share, remember I told you they're going to share that base side. It's going to form a straight line, so that's how you know it's a linear pair. All right? So we have the measure of angle 5 plus the measure of angle 6 equals 180. Our next pair that we're going to use is angle 1 and angle 3. This time, instead of going left to right, we're going to be going up and down. So again, look at it. It's, as I'm drawing my mark here, you see that they're sharing that base line. So here's the measure of angle 1 plus the measure of angle 3 equals 180. All right? So that covers all of the ones that we're going to deal with on this particular side of the notes. On the other side, I'll go over that in the next video. But again, guys, make sure that you fill these out. I'm not doing it just to hear myself talk. I'm here to do this to help you guys. Because remember, if we were here, we'd be doing this in person. But anyway, I'll talk to you in the next one. Bye.